You need to count down.
Okay, so live in the room. Live in the. So let me start off by asking this question. So if I may ask, let me start off from you. Can you rate like within the range of 1 to 10? Let me ask 0. Rate your likeness to maths, like how do you like maths? 0 to 10.
You're 0.
Just because. I'm not saying we know, right? Feel precise.
I'm not saying.
So does it mean you don't really like maths or hate maths? You like maths. So just give it a read. Just give it a read. Not be truthful. Let me ask someone else. Sorry. If I ask within the range of 0 to 10, rate your likeness of maths. 6, Abby. You said 6, right? What about you?
0 and
0, Abby. 0. They play. I know you are counting. Let me ask someone that will be sincere. Like within the range of 6 to 10. Sorry, 0 to 10, rather. 0 to 10. 5. Said 5. Someone else said 0, right? And someone else said what? She doesn't. That's undefined. Okay, let's put it this way. The thing there is that something about problem, if you have an issue, the moment you what's it? Like the moment you actually hate it and you see it as a big mountain, something impossible to dissolve. The more you focus on it, the less you focus on it, right? For instance, if you take a look at maths, those who that actually detest maths, how did you see them go through it or read it right? In the sense that whenever they see maths, let's look at this maths, whenever they see maths, it's always something like a big issue to them, right? So let's have this type of expression. As far as a big issue. Okay, let me try it out again. I can't know this math. This math, I can never know it right. I can never know it. It's something wide that's quite difficult. Right? And the moment you start, the more you hate it, the less you study it, Abby, and the less you are familiar with the so-called course, which is heavy, and that will still be replicating your unknown or your hatred reaction to that particular course. But it's something about problem. The more you embrace a problem, the more you come to the problem. That is when you now see a solution to it. Remember to realize that a problem is a pathway or a bridge to success. That's why I said the moment you must undo it, just like this X sign. The moment you undo it, they will be having the opposite reaction. In the sense that you are going to the opposite of horizontal is vertical, right? In the sense that this can just change to here. And the opposite of N is what? U R B. I believe that it has its own complexity. Same goes to other courses too. Don't say it from after that, oh, this course is stupid. I can't do it. The moment you start saying that, trust me, you won't know it. So you start, first of all, start with affirmation that maths, I like it, not that maths, I hate you. You start from affirmation. And from affirmation, you now proceed to the work, like action of a king. You put it into action, like you being consistent with your study and so on and so forth, not you just as a big bridge. So, okay, by the way, Infinity, I believe because of your name, right? So, so now moving on. In today's class, we'll be talking about the application of, not actual application. Since we are familiar with that, we're talking about more or less of a preview of. When I say divide dx, I mean differentiation. There will also be talking about profit maximization. Sales maximization. And if we go, what I'm talking about demand and supply. So I think I actually work too. So I believe majority of us has idea about what differentiation and integration entails, right? But so it's just be more or less of the revision class. So let's take a look at this simple question. If we're having y equals to y equals to 6x plus 5x squared minus 2x cubed minus 4. Okay, this is an equation, right? And if you might be told that find dy all over dx. What this means is the derivative of y with respect to what? X. Differentiate y with respect to what? X. In some questions, you might have more than one variable here. You might be saying x, you might see b like on that variable. But what are you trying to tell us? Whenever you are differentiating, focus on what? X and see other variable or other stuff there as numbers. That's it, but that's not our main focus. So moving on, how do you differentiate? It's quite simple. All you just do is that minus 1 from the power, then add the power to the back. Yes, like minus 1 from the power, add the power to the back. In this sense, what's the power of x here, or the exponential of x? It's okay? 1, right? So this power, I bring it back, meaning you're having 1 times 6 having. I remember minus 1 to the power, having 1 minus 1, isn't it? Then here, do the same thing here, to the back, right? 2 times 5 minus 1 from the power, 2 minus 1, right? Same also applies here to the power to the back, 3 times 2x, 3 minus 1. Okay, we are going to I state that 4x raised to power 0 is the same as 4. Do you agree? Do you agree?
Yes.
What's the boyfriend raised to power 0? 1. Your boyfriend raised to power 0. Your boyfriend raised to power 0.
1.
My two is not raised. My two is not 1. My 2 raised to power 0 is not 1. 1. Eh? What is 0?
That is not working.
Oh, after that, I've tried it out. I have in the library. So moving on, the thing here is that anything raised by 0 will definitely give us what? 1. This here seems as 4 times x raised by 0, right? Meaning that you're having 4 times 1, which will give us 4. What I'm trying to say here is that this 4 here, this 4 you are seeing, is the same thing as 4x raised by 0. Is that clear? And please note, whenever you differentiate a constant, we always have what? 0. The derivative of a constant is always 0. The derivative of 10 is 0. The derivative of 10,000 is 0. And the derivative of 100,000 is what? 0. That's the reason why here, if you want to differentiate this, like this for here, we're having what? Minus 0. Is that clear? So now let's simplify this. We're having 6x raised by 0 having plus 10x raised by 1. The same thing as this. Minus 6x raised to power what? 2, right? And this is there, so it doesn't mean anything. So it means you are having dy all over dx equals to 6x raised to power 0. And 6x raised to power 0 is as what? 6, right? 6 plus 10x minus 6x squared. So this is our answer, as simple as that. But before proceeding, I would love to ask 3 questions. Yes, I would love to ask this question. I'm looking for beautiful faces. I don't know what this is. Okay, let me ask you, what is the opposite of I am a dollar? What is the opposite of I am a dollar? I am brilliant at being. If I may ask you, what's the opposite of I am ugly? Eh? You are beautiful.
I am ugly.
Yes, what's the opposite of I am
I
ugly?
am ugly.
Let me tell them that means a beautiful lady. What's the opposite of I am ugly? Beauty.
I'm the opposite.
What's the opposite of I am ugly?
Exactly, I'm the
I'm beauty. Okay, let me ask you, what's the opposite of I hate you? Wait, you got. You said she loves me, right? Yeah. Okay, you're going to be asking that. What am I trying to derive here? But let's be this one. What's the opposite of multiplication? So, like, what's the word at opposite? Word at opposite that you guys did in your primary school? What's the opposite of multiplication? Division, right?
Close.
What's the opposite of subtraction?
Plus.
Addition, right? I'm going to agree with me on this. What I'm trying to point here is that differentiation and integration, they are more or less of word and opposites. How? Okay, right with me. When I differentiate this, I have this, right? If I should integrate this, I should be having this. Exactly. When I differentiate this, I have what? This. If I should integrate this result, I should have this. And remember, when I was differentiating, what did I do? I multiply and I what? Subtract. Isn't it?
Yeah.
If I'm integrating, I'll be doing the opposite. Or rather, let me say the inverse. Remember, I asked that what's the opposite of multiplication?
Division.
So instead of multiplying, if I'm to integrate, like the integral of 6 plus 10x minus 6x squared dx, how do I integrate? Instead of me to minus 1 from the power, I will be adding 1 to the power, the opposite. In the sense of, okay, remember I told you guys that this 6 is essentially now 6 x raised to power 0, isn't it?
Yeah.
Like the power of this, the power of x is what? 0, right? So I'll add 1 to the power, like 0 plus 1, right?
Yeah.
Here, I multiply, but since it's integration, I'll ask you the opposite. What's the opposite of multiplication?
Division.
You divide by the result of the power, 0 plus 1. That's how you integrate. Then plus, do the same for the rest. What's the power of x here?
Power of x there is 1.
1, right?
Yes.
I'm having 10x raised by 1 plus 1, right?
Yeah.
Divided by 1 plus 1. Power of x is what?
2.
I'm having 6x 2 plus 1 divided by what? 2 plus 1. And we often add a constant,
Yes,
which we call k.
k.
You're asking that why do you add a constant? Remember that constant is with respect to all real numbers, from your positive octave down to your negative octave. And we have a lot of numbers. This was uncountable. So, due to the fact that we can't know the exact number, we use k to represent it. We tell them maybe it's 10, maybe it's 6, maybe it's 4. So rather, we now use k to represent that this means a constant. Remember, when you use the constant, you have what? 0. So this is the fact that we can't ascertain that without giving additional information. We often make use of this k. For instance, there's a constant that is still yet to be what? Filled in. So simplifying this, we're having 6x raised to power 1 divided by 1, right? Plus 10x squared divided by 2 minus 6x cubed divided by 3 plus k, right? So here we're having 6x plus 2 here 1, 2 here
5.
5s squared minus 6s cubed plus k. That's the integral. If you
No,
don't
like
get
3s cubed.
sorry, 3 here 1, 3 here
2s
2.
cubed.
Abi?
Yeah.
So here we're having 2s cubed plus k, right?
Yeah.
That's correct, isn't it?
Yeah.
And if you compare with this, you're told that they are the same. 6x plus 5s squared minus 2s cubed plus k. This k here, this is it here. So now this is where I start differential integration. They are more or less of word and opposite. If they look at this, when I differentiate, I'm having this. When I differentiate, I'm having this. This means differentiation place. By this prime we are saying. Whenever you see, it means what? Differentiate or the derivative. I'm having this. This means let me differentiate twice. That means like differentiate it twice. Now see, we're having 2 marks, like fiber mark there. We're having this. But note, when we integrate, we have the opposite. The opposite of horizontal is what?
Vertical.
Can see we have a vertical stuff here. And the opposite of n is what? I can say that the expression changes. Simple as that. So I'm using this to explain what differentiation and integration is all about. You wanted to?
I have a question. In your last class, you made mention of differentiating twice, like there was something differentiated twice, but I was not really paying attention. So if you have to differentiate twice, is it the equation itself, or when you differentiate the first one, the result you have differentiated again?
Exactly. It will be the result. For instance, if I'm to differentiate this twice, this is what I'll be differentiating my second derivative. Okay, so now moving on. You have a question, you can go.
Yeah. Will they show us that we're supposed to differentiate twice? Like, will they show us that we're
Yes, there will.
How?
No, we just was what?
Depends more or less.
I thought that we just put like a sign there since they didn't come from there.
Though this, they will not
So
actually see
maybe
this kind of
divide
thing,
here.
but they say to divide this thing because it's not integration we're doing. We're not doing integration integration. It's application we're going to do. So it will be relating to.
Okay. Thank you.
Okay, so now moving on. Please, sorry. Moving on. So now let's move into the first topic we have there, cost and revenue function. I believe you actually have idea about this. Our main focus is how is it being applied, like how is differential integration applied to this. So I hope you are clear here, right? So this one I did not mark. How is the theory of differential integration applied to this cost function, right? So I will be talking about the definition of cost. We are not doing ECM class, right? So I don't need that. Rather, it's a practical part we'll be doing, not the rest of it. But I'll just give you guys an overview. So you agree with me that if you want to have a girlfriend, there's a particular cost you surely incur. Urgent to kill. Valentine. Best take money out. And if you also carry Olosho too, they also a cost you also incur, right?
Yeah.
Isn't it?
Yeah.
Like the what they call it, the Wababa you buy to do the do. That's also part of the cost you are incurring, right? So in every choice or every decision you make, you actually make a cost. Either it is monetary or it is what non-monetary. But in accounting, we focus more on the monetary cost. Now to dive in, let's go back to math schedule. So now moving on, under this, we're talking about three main concepts, which are talking about your total cost, your average cost, and your marginal cost. From the word total, that's talking about summation or cumulative, right? Like addition of all costs you have. That's what this talks about. So we have all these three stuff as their respective formula. For total cost, it has up to, let's just say three formulas. The first one is this. Total cost is the addition of your variable cost and your fixed cost. That you're not asking that what is variable cost and what is fixed cost, right? Variable cost is the type of cost that varies or changes as your level of your output increases. Remember the word variable there, trying to tell like what varies. That's what it means. Why fixed cost is the type of cost that remain constant. It remains the same irrespective of the output you are producing. If you are producing 10, it remains. If you are producing 1 unit, it remains 10. If you are producing 2 units, it remains 10. If you are producing 100 units, it still remains what? 10. That's for fixed cost. So you might be wondering that how do you differentiate this in a particular equation? For instance, let's take a look at this equation. I want to express this as having C, that's my cost, equals to 6x plus 5x squared minus 2x cubed minus 4. I know that we are familiar with this. Like the equation being this form.
Yeah.
Like them using Q rather than what? X.
Yeah.
When Q means quantity, right?
Yeah.
But in math, whenever you say the variable X, used under production, it means what? Quantity. You won't be seeing Q. And if you see Q, most time you see what? X. Is that clear? It's still the same thing. I just change the variables. Rather than having X, I have what? Q. Is that clear? So, which one is my variable cost here? And which one is my fixed cost? I want to differentiate. Remember, I said that variable cost is a type of cost that changes or varies as the level of output changes, right?
Yeah.
Anyone that have the attachment of X, we often see it as our variable cost. Due to the fact that as X changes, the variable to also was changes. I don't use each big figure as this one. Let me just pick one of them, like the 6X. When my output is 1, my variable cost will be 6 into the bracket 1, Abby.
Yeah.
I'm having 6. When output is 2, I'm having variable cost equals to 6 into the bracket 2, Abby. I'm having what? 12. When output is 3, I'm having what?
6 into bracket 18.
That's 18. You observe that as output changes, what happens to the variable cost?
The cost increases.
It varies, right? It changes too. But the fixed cost here is the constant you have. Look from the word fixed cost. That is the cost that remains constant. Any constant you have in the expression or in the equation is often seen as the fixed cost, which is this. We observe that when output is 1, what's your fixed cost?
4, sorry.
4, right? When output is 2, what is your fixed cost? 4. When output is 10, what's your fixed cost? 4. You can see that it remains the same. So differentiating this, I can see that this part is my what? Variable cost, and this part is my what? Fixed cost. So the fixed cost represents the constant in the expression. As simple as that. That's which we're expressing to the first formula. And for this, when you hear the word average in economics or in math, it means per, right? It means per, in the sense that the cost per unit of output produced, the formula here is TC all over Q. Your total cost all over quantity T. So I told you guys that we have more than one formula for your total cost, right? You can also state that your total cost is equals to your average cost times Q. You ask me that how do I divide this, Abby? It's gotten from this. Any of the two. You observe that here we have TC, Abby. If you take TC, subject of the formula here, you have this. In the sense of AC equals to TC all over Q, Abby. What's about buying not? Because not you are having AC times Q equals to 1 times TC.
Yeah.
AC times Q equals to what? TC. Same as TC equals to AC times Q. That's how it's going to divide. So this formula gives us this formula. Is that clear? And another stuff I want you guys to take note is that whenever your output is 0, your total cost equals to your fixed cost. We also say that fixed cost, another name for fixed cost is unavoidable cost. I'm going to repeat that again. Another name for what? Fixed cost is what? Unavoidable cost, or we call it overhead cost. It's the cost that you can never avoid. You always incur it if you are producing or you are not producing. Take a look at rent as a case study. If you rent a particular apartment or a building, if production goes on, will you pay rent? If production doesn't goes on, will the rent still count?
Yes.
So you can see that production, if you are producing or you are not producing, the cost is you still incur that particular cost. That is why I call it unavoidable or what? Overhead cost. So whenever I say that whenever Q, that's your quantity, equals to 0, your TC is equals to your fixed cost. That means whenever you're not producing, you will always incur a fixed cost. That's what I'm trying to say. Is that clear?
Yes,
What do I mean by that? Let's try to particularize using this example. I say when x equals to what? 0, that's your Q equals to 0. You'll be having C equals to 6 into bracket 0 plus 5 into bracket 0 squared minus 2 0 cubed minus 4. Tutorial.
It'd be 2 attributes. 210.
Okay, so now moving on, simplifying this, you'll be having C equals to 6 times 0 is what? 0, Abby. 0 raised by 2 is what?
0.
0 times 5.
0.
You can say plus 0 raised by 3. 0 times 2.
0.
Okay, this is minus. Then you're having minus 4. So you can see you're having 6. C equals to minus 4. And your C is what? Your total cost. You can see that whenever your quantity is 0, your total cost equals to your what? Fixed cost. That's what this comes in. Is that clear? So that's for the formula. So the next one is what they call the marginal cost, which we also call incremental cost. That's another name for marginal cost. Whenever you hear the word marginal in economics, it's always with respect to additional. The additional cost you are incurring in order to produce extra units of a commodity, right? That's what this is with respect to. And how do we get the marginal cost? The marginal cost is always derived from your total cost. That's when differentiation and integration set in. Just as we're talking about this application of the YDS and integration of business applications, we are relating to, most times, we are relating to AC and MC. That are the prime foundation of it. Is that clear? Because of that's where differentiation and integration will be more drilled or more talked about on. So how do you get your MC? You can get MC by differentiating your total cost. MC equals to your differentiation of total cost with respect to output. Remember that the y over the x means differentiate y with respect to x. This means differentiate total cost with respect to quantity. Is that clear? Yeah. So remember, I told you guys that the differential and integration, they are word and opposites. If I differentiate this to have MC, explain means if I integrate MC with respect to x, I should have
CC.
Is that clear?
Yeah.
So let's take a look at the question of that so you understand what is copying. So do you guys have simplification about complexity material?
Yes.
Okay, if you do,
Some don't have.
some have, some do have. I supposed to push you guys from my class. Okay, so our example will be taken from there. So actually you can get it. Don't worry, don't get it for the price. Medium copy. Medium copy.
Soft copy.
Can you make
Soft
it
copy.
in PDF? Can you bring it
Soft
up?
copy.
Make it in material.
Soft copy is what?
It is soft. It is soft.
No, I said, can you make
Soft
it?
copy.
Okay,
So that
when you buy it, you can print it out yourself.
Alright.
okay, so the actually material entails everything that we'll be talking about this semester, and it is quite comprehensive. It entails everything, both mathematics, trade, and so on and so forth. So that's where our first example will be taking.
How much is it?
How much is it? No, it's DM.
You
No,
want to buy DM 50.
so moving on, the first question will be we're talking about taking from like simplification over complexity, page 54, the example 1. Don't worry, we should just send a screenshot of that to the group. Take page 54, example 1. You can just go to the achievers group. We'll send it there.
Who sent?
Okay, let's do that way.
Abigail.
Or let me help you line. You guys, okay, he's going to send, if you have lecturer's slide, the slide that the lecturer used, that is Dr. Adeleke. You can check the example 1 he gave in that slide. It's not the same question. Dr. Page 54, example 1.
Resend.
So are you saying, or if you have Dr. Adeleke PDF, is there to the first example taken? So you are still waiting. So in the course of that, I want guys to take note of this. You know, some people might have thought already. I'm saying something over there, sitting on that. But let's just take note of that. We'll come back to it very soon. After attempting the question we are about to take. Evening. Afternoon. Morning. Evening. Morning.
There's no bite side for you.
Okay, sorry there. Are you saying it?
Yes, yeah.
Okay, now let's okay, sorry. I think it's on. Can you call the question, please?
Don't you read the question out?
Who wants to read? A beautiful girl with a beautiful voice.
I see, I'm looking at someone.
As anybody said.
Like anyone who wants to volunteer and read for us.
Okay, let me hear this.
You are listening.
The marginal cost function of manufacturing.
Just say, it's right there, I'll just can see pounds.
The marginal cost function of manufacturing X shoes
Yeah, I'm listening.
is 6 plus 10x minus 6x squared. The cost of producing a pair of shoes is 12 naira. Find the total and average cost of production.
I love your voice. My girlfriend is saying, you have to know it. Can you call it again? The marginal cost of
The marginal cost function
that is your MC. MC normal.
of manufacturing X shoes
X shows. That's the quantities shows, right? Which is X.
is 6 plus 10x.
6 plus 10x minus 6x squared.
The cost producing a pair of shoes is 12 naira.
The cost of producing a pair. Okay, let's try to. What's the question? We want to take this
Find
step.
the total and average cost function.
The question asks us to find the total and average cost function, right? Remember, to find our total cost, if we're given marginal cost, what do? We just have to integrate, right? Remember, TC is equals to, let me this one, TC is equals to the integral of condu, embrace it, embrace MC, dx. You have your TC. So TC can be equals to the integral of MC dx, isn't it?
Yes.
So it's going to be having this. Right? Dx. So let's integrate. Remember, what is the coefficient? What is the power of x here? Let me ask. I'm sorry, ma'am. Oh, sorry, ma'am. If I may ask, what is the power of x here? What's the power of x here? Okay, like probably 6 here, Abi. It is 6 here. Can you just the power of x here? What is the G variable?
0.
What is the G variable? So what is it? It's 1, Abi. The power of x here is what? 1, right? Right? You will agree, it's 1.
Yeah.
So it's really means 6x raised by 1 is equals to 6, Abi. Abi? I'm not the author's guy this was, isn't it? Not me. Okay, if I may ask, what is the power of x here? Like it is 6. 0, right? Remember, when it's going to explain that 6x raised by 0 is equal to what? 6. Use the fact that any raised by 0 will give you what? 1. So here, the power of x here, like this here, the same thing as 6x raised by 0 plus 10x minus 6x squared dx. Hey, sorry, I hope you understand why it's 0. Yes. One person has been coming. That is what I'm asking. So now moving on, remember how we integrate, add 1 to the powers and divide by what? Results. So let us see here, we're having 6x 0 plus 1 divided by 0 plus 1, right? Then plus 10x 1 plus 1 divided by 1 plus 1 minus 6x 1 plus 1 divided by 2 plus 1 and b. I start when we are integrating. What is add what?
1.
What is add was 1?
Plus C.
Plus c and b, but I'm using k.
Yeah.
You have to prevent repetition because of most times this TC can be written as C. Is that clear? So I will be using K to represent my constant, not C. C also means constant too, but to prevent repetition of alphabets. So I'll be using K. So let's simplify this. We'll be having C, that's our total cost, equals to 6x plus 10x squared divided by 2 minus 6x cubed divided by 3 plus k, right? Initially, we saw this question. We have c equals to 6x plus 2 here 1, 2 here 5x squared minus 3x1, 3x2, 2x cubed. But the question has to find the cost function, right? The total cost, Abi. But before that, before we proceed, Kelechi, say
Those values. Average cost.
yeah, let's find average cost too, right? Before proceeding, say question 24. The paper. I said before proceeding. Before proceeding. You can check it. Send it to me. Don't be afraid. So it's going to say in another question. You observe that these two questions are the same. Remember, our exam is CBT, right? You actually have to work smart, not hard. From this point, you can actually get your answer without even solving. By comparing your options. That is why it pause first. Let's say we have a particular option that's just unique. If so, we'll pick our answer. But if not, we have to proceed, right? So let's look at the question is sent. Have you sent it? Okay, we are waiting to go too fast. We define your thing. Send, okay, can I see the question, please? So let's look at the options. What's option A? You also go to find the cost function. Option A says what?
Anyone volunteer?
Option A. No PCM.
Send it to the 200 level.
60 over X.
Okay, actually class so. Okay, TC. That's total cost.
Equal to 6 plus 15x
Equal to 6
plus 15x
plus 15x
minus 2x squared
minus 3x squared
plus 2 over
plus 2 over
2 over X.
2 over x.
3 over x. Option B. Okay, wait, those find. What do they actually find?
Average cost.
Average cost there. What does option B state?
6 plus 5X.
6 plus 5x
Plus 2X squared.
minus 2x squared
Plus 3 over X.
plus 3 over x. Option C.
5 plus X minus X squared plus 5 over X.
5 plus x
Minus X squared
minus x squared
plus 5 over X.
plus 5 over x, Abi.
Yeah.
Option D.
2 plus X.
2 plus
X minus 3X squared plus 5 over X.
Okay. As I stated, from this point, you can get your answer. These are our TCRB. But the question asks us to find AC. Same both the question we also asked. We're going to find both the cost and average cost, right? Remember, average cost is equal to total cost all over X, Abi. So to find our average cost, what we have to do is just divide this by X. We have our average cost in the sense that average cost equals to TC all over X, Abi, equals to 6x plus 5x squared minus 2x cubed plus k, all divided by x. So give them, distribute it.
What is that going to
Right?
Yeah.
So simplify. This cancel out this. You're having 6. This cancel out this, Abi. You're having 5x. And this makes this 2, Abi, minus 2x squared plus k all over x. So you observe that the options are looking unique. They're not the same. So without solving for my k, I can pick my answer. Just my compare. Can't you see the answer there?
Yes.
If I absorb the answer,
Key.
that's for k.
No.
And I already have what? K as an answer. So that is why
Can you
I
explain
by.
what you just did now? I'm lost.
Okay, what I did now. Okay, I'm coming. Okay. Going back again. Remember, what was enough for your average cost? Your total cost divided by your what? Quantity, right? This is the total cost. We're going to find our average cost. Divide the expressions out here. All of them, not just pick some of them. Pick everything. Accumulate everything. Bundle everything. Press everything. Divide by x. Can see?
Why?
Eh?
Tell them the reason why.
Why? What's the most fucking? Sorry. You will put. That is why I did this. Why are we doing this? The formula. Remember what average means? It means path. When you hear the word average, path. Your average boyfriend, your pal boyfriend. That's what average means. Why is it? They just impute it. But why this particular, I get that part. But in this particular question, we're not.
Really, I don't see any question there.
There might be some scenario where you're giving a quantity. Then when you got it out, you can just impute it. So now moving on. Okay, so moving on. I want guys to take note that if we have something like this, x plus y divided by a, it's the same thing as x all over a plus y all over a. Remember here, is it here? This one.
I don't know. Where did you guys start studying from?
When you are solving individually, basically question yourself.
No.
Okay, so here's the question. Have you seen the question?
Okay.
You've seen the question. We know that MC is given as this. We're told to find our total cost and average cost.
Okay.
Exactly. And there's also another question. The options we're giving, I was using that. Remember, how do you get your marginal cost? You integrate your. So how do you get your total cost? How do you get your total cost? You integrate your marginal cost. What I have here. In what was the marginal cost?
Yeah. I understand everything to do.
Then we have cost equals to this, right?
Yeah.
Clear here,
Yeah, clear.
so how do you get to average cost? Average cost equals to total cost all over Q. We're just doing formula application. Now see, I told you guys that in math, whenever you see Q, it means what? X. Most times you use X to represent Q. Only you see them use Q. They'll be using what? X. X will be used to represent the quantity and the output. Is that clear? That's the reason why here you see Q here. You see what? X. The X means your output. Is that clear? So moving on, I have this. As I've stated, x plus y divided by a. The same thing as x all over a plus y all over a. How? What's LCM here? A. It's more or less of distributing it. Same applies here. Like I distributed it. In the sense of this. 6x divided by x, right? Plus 5x squared divided by x minus 2x cubed divided by x plus k all over x. Then you simplify. X cancel out x, you have 6 having. This cancel, this one becomes what? 1 having.
Yeah.
You're having plus 5x. And this becomes what?
2x squared.
Minus 2x squared plus k all over. Is our average cost. Is that clear?
I get it to this point. So how did you know your case? Was it given?
Remember, I told you guys that our exam will be CBT. You have to work what? Smart, not hard. If not solve your K, you'll be utilizing or using up to 30 seconds or depending on your speed wise. Some might use 1 minute, some might use 30 seconds. So that 30 seconds actually save it. What you have to do, complete what you have here with the result or with the options. Due to the fact that they are unique, they are not the same. Assuming they were this, assuming you are having 6 plus 5x minus 2x squared plus something else here, they will not have to solve. Due to the fact that we are having 2 options that look the same. But here, all options look what? Different.
Okay.
Exactly. Because that's all the options look different. So easily, don't stress yourself. Don't solve for K.
But how do we get it?
K, that's something. Remember, what I'm talking about here is how to work smart. Not don't do all cost of D. Yes, I'll try to tell you guys how to get your key. But this particular question, I like to tell this question, this is one that is quite subjective. The way our lecturer solve it is quite different from the way you might find it online. How? Calm down, you'll soon see what I'm trying to talk about. Can you read the second sentence of the question? Everybody take a look at the second sentence. What the second sentence states?
cost producing a pair of shoes is 12 naira.
English. English to what? He said the cost of producing a pair. So if I may ask, what does pair represent? When you hear the word pair, two, as he someone said two. Is it just two? You say what? Why? No wait. So everything is correct. Let's use actually correct. Powerful. There with you. Also, is it two? Do you all agree? Or you have contradicting opinion? Pair. Is pair two? She's looking down, so I will not call her. He said, is pair actually two? Do you agree that pair is two? No contradicting opinion. One, Abi. Okay, if I ask, why do you say pair is two? Why do you say it's one?
A pair.
Okay, you observe that in an organization producing maybe shoes, socks, or sneakers, if you think about pair, if when I want to go and buy to get this, did I just buy this?
No.
I bought both. They are seen as single commodity.
Yeah.
I can just call it one. When they are also counting, they count it in form of one commodity, two commodity. They don't say 1, 2, 3, 4. So if I say x equals to 1, I'm correct. If I state x equals to 2, I'm also correct. It's a subjective stuff. Like, it's a subjective stuff in the sense that it's based on how you are building it, based on your perspective. When the lecturer was solving it, he said that x equals to 2. If you repeat as 2, not 1. Remember, we have a particular question on this, right? So, we are asking me that how can we get k? How can we get k? So that's what we're thinking about now. How can we get it constant? So I'm going to rewrite this.
Oh my God.
Cos equals to 6x plus 5x squared minus 2s cubed plus k. And the question is that the cost of producing a pair is what?
12 naira.
12 naira. So it's when x is a pair, we are having our c. That's our total cost as 12. When x is equals to 2 in the sense of a pair, right?
Yeah.
Total cost is equals to 12. Anywhere you see x, put what? 2. Come on the x and put 2. We are having c equals to 6 into the bracket 2 plus 5 into the bracket 2 squared minus 2 cube plus k. So like as one more c was given as 12. So instead of writing c, I'll write what? 12. Is that clear? So simplify this. 12 equals to 6 times 2. 12 plus 2 squared. 4 times 5. 20 Abi. 2 cube. 8 Abi. 8 times 2. Minus 16 plus 8. 12 equals to 12 plus 20. That's 32 Abi. 32 minus 16. That's 16, right? So 16 plus k. Collect like terms. This should come to the other side. Whenever plus equals over equals to side, change to the opposite side. Minus equals to k. 12 minus 16 minus 4. Like your k equals to minus 4. We saw for k Abi. So here we are having our total cost equals to 6x plus 5x squared minus 2s cubed plus
Minus k and minus 4.
Abi 5 times plus times minus. Is that clear now? So in this particular question, let's solve for the average cost.
Why did the lecturer use 3 instead of minus 4?
Let's solve for the average cost. So okay, solve for the average cost. We have this. Say something.
No, right now.
You're agree with me. So simplifying this, we'll be having 6 plus 5x minus 2s squared minus 4 all over. Take a look at this option. Is that there? Does that mean we are wrong?
No.
So you can see that this particular question is based on perspective. So you're asking that why am I having plus 3 here and you're having what? Minus 4. If you take a look at the lecturer slide, this was what he asked as your AC. You can check the lecturer slide. Or does anyone have this? Just send the screenshot so everyone will see. Make it not be asked by the lie or in the card. So if you take a look at it, this is what you have as your average cost. But there's another question we asked. You know there. That doesn't mean we are burning. Remember, I told you guys that stating that S equals to 2 is quite subjective. So let's try solving by stating when x equals to 1, still a pair. TC equals to 12, Abby. We are having 12 equals to 6 into bracket 1 plus 5. We are still using this, so 1 squared minus 2, 1 cubed plus k, right? Simplify. We are having 6 plus 1 squared is 1. 1 times 5 gives you 5. 1 cubed is 1. 1 times 3 gives you 2 plus k, right? 12, 6 plus 5, 11, Abby. 11 minus 2. 9, Abby. 9 plus k. 12 minus 9 equals to k. 12 minus 9 is what? K. Meaning k equals to 3. So putting it back here. Putting it back here. We are having c equals to 6x plus 5x squared minus 2x cubed plus 3, Abby. So let's find our average cost. Divide all through by x, Abby. 6 plus 5. Okay. So I don't understand. All divided by x, right? So 6 plus 5x minus 2x squared plus 3. So if this is particular question, just solve based on your lecturer's perspective. This is actually a PQ. Our previous set were asked, and the answer in the options was this. So exactly.
I don't have no answers.
They never.
Are you sure?
As I said, there is a PQ. Right? The last set, this was part of their test questions. And this was what was in the option, not this. And the option were quite different. That is okay, you can still get your answer. Exactly. But just taking it, you can never have both options in a single question. So, any questions so far? So, I want you guys to try out a particular question. Everyone will try it out, please, if you understand that. Simplification over complexity material. Page 55, example 2.
Page 55 example.
Or if you have the lecturer's like Adeleke, you can take a look at the example 2 there. You send Navi? Send. Send. Let's attempt. I will answer the question now. Let's try it out.
As we should do it.
Yes, in the have you gotten the answer yet?
The last question.
Please let's attempt.
Don't stand up, please.
And yes, they do.
The answer is
More valuable.
no more bad.
But of 60
No, you give it
Please let's not debate ourselves.
Got it.
Can you write the question? People that don't have the answer.
We have come with the answer.
Hold on, don't be selfish.
Say it. What's your answer? Write it.
Because I know that I'm not supposed to.
Attempt.
Yes.
There's no harm in trying.
What goes to
I didn't know the question is, so I just jotted down some points. Yeah. Wait. That's like
What's number 4?
what wrong?
No.
What 3125?
Okay, so
3125 is the answer.
okay, so now what's the answer? What do you have?
3125.
3125.
When there's so
3, 1, 2, 5. What page are we?
I didn't want to try.
Right? So let's make that
Let's
correct.
try.
Who wants to delay the question? The question.
What should we do? Should I read out the question?
Yeah, you can read out the question.
A company has determined that the marginal cost function. A company has determined that the marginal cost function for a product of a particular commodity is given by. So marginal cost is 125 plus 10x minus x squared divided by 9. Where C rupees is the cost of 9 producing units of the commodity. If the fixed cost is 250, what is the cost of producing 15 units? If the fixed cost is 250, what is the cost of producing 15 units?
So this is the question. So we'll talk about all this kind of question. Don't see it as something. Don't see it as something new. Okay, so don't see it as something huge. Rather, take it step by step. Take it from step by step. In the sense that, start from the first sentence. Say that the marginal cost of producing blah blah blah. We're given the marginal cost function as 125 plus 10x minus x squared divided by 9, right? There was also another sentence at the page. Don't get confused. Actually ignore it. And that we're talking about how you can find your fixed cost. That was given already. So ignore it. Exactly. We're told to find the cost of producing 15 units, Abby, isn't it? So first and foremost, we have to articulate our total cost function. How do you get your total cost? When you are giving your marginal cost. How do you get your total cost when you give marginal cost? You integrate, Abby. Like in the sense that total cost is equals to the integral of MC dx, right? So here we can have total cost equals to integral of 125 plus 10x minus s squared divided by 9 dx. So moving on, now let's integrate. Remember how to integrate. Add 1 to the power divided by the result. The power of x is what? Okay, we're having 125x, 0 plus 1. 0 plus 1, Abby. Plus the power here is what? 1 plus 1. 1 plus 1. And the power here is 2, Abby. This here is 9, Abby. Remember, divide by the result.
3 well.
Right? I don't want to complicate things. From here, I would have said 9 times 3. Like from this point. I just say x is about 3 divided by 9 times 3. But you asked me that how did I arrive there? That's the reason why I'm taking my time. Plus what? K. So let's simplify. What's 0 plus 1? 1, Abby. Divided by 1 plus 10s squared divided by 2 minus s raised to the power 3 divided by 9. Then your division sign, Abby. 3. All divided by 3, right?
Yeah.
So, 125x. 2 here 1, 2 here 5, Abby. 5s squared minus s raised to the power 3 divided by 9. Okay, sorry. Go fast. Okay, so now moving on. In maths, when division changes to multiplication, what happens?
Denominator turns to
Like when you and your boyfriend are doing and you guys want to change side, what happened?
You like this example?
And you guys change, what happened? You want to switch. Your boyfriend coming up, you going down. So you're able to hammer very, very, very well. Then also, how do you switch? Then I think that you can try it in mainline. I'll show you how we switch. So what I'm trying to say that in maths, whenever division changes to whenever division rather changes to multiplication, the other fraction you have, it reciprocates. Reciprocate in the sense that the numerator and denominator switch. They switch the side. So if this division, remember this 3 is equal to 3 all over 1. Do you agree with me?
Yeah.
So if this changes to multiplication, the have to switch side and be having 1 all over 2. Is that clear? Come again.
Explain to me like I'm in KG1.
Excellent. Let's do this point, Abby. Okay, so just imagine that you have a human and you should know that you should be of age. And you're a brethren that really need food. Yeah, you really need food on bed.
Which need food? You don't need food.
They need
No need
food.
food.
I really need food on bed. And all of a sudden, it was like, I want to go deeper. Let's have to switch side. In the sense that before you were up, you were riding up, and it was down. So I was like, I want to go deeper. Switch side, they said that it is now coming up, and if you are down, they didn't need food.
But she can go deeper when she's up.
You've done it before. And if you want to go deeper, right? Meaning you are now down, it's up. You see that it's a very switched side. So take note that in math, if you have a fraction, and the sign there, the sign between them is division.
What did they do?
We can actually change it to multiplication or a given condition. If the division is multiplication, the numerator does not have to swap. And they have to reciprocate. This 3 here, and this 3, same thing as 3 over 1. So if they swap, this one comes up, this one goes down. 1 over 3. So swap Abi. So now moving on, let's simplify. We're having 125x plus 5x squared minus x cubed times 1 is what? 9 times 3 is what? 27. I forgot my k. I didn't ask me to add my k. I added k here. And I also have to add k here. Then I add what plus k. Right? And I told you guys that the constant is respected to the what? Piece cost. And we're giving that 250. So only for it to solve for it. So rather than writing k, you write what? 250. Like when k equals to 250. That's the piece cost. So this premise here, you can easily have you can have your total cost equals to 125x plus x plus 5x squared minus x cubed divided by 27 plus 250, right? We're told to find total cost when x equals to 15. Our exam is CBT. No need for you to start doing problems or deep. Easily, you can use a calculator from here. Since this is an equation, right? Just substitute the value of your x here. I'm just going to solve manually. Will save you of the stress. Anywhere you see x, put what? 15.
Yes, sir.
In this sense, 1 and 25. 15. You see that?
No.
Can you see my team? My team there.
Nothing is not clear.
You can't see my team. The short
Very small.
is blurry. It's small.
Yeah.
Can we all sit now?
Can think be blurry.
Okay,
What's
15 in
that?
brackets, yeah.
Like you can take out the calculator too. Press 1 and 25. Open a bra. Open a bra. Write 15. Then if you open bra, what happened? You leave the bra, make them see your thing. Close the bra, Abi, to be safe. Then plus 5x squared, Abi, plus 5. Open another.
Those will not get brown.
No.
You jumper.
Then square, Abi. Then close your bra. Then minus. This is a fraction, right? We also have fraction here too, like the fraction sign. So in the numerator, we have s cubed. That is 15, your power 3. Then come down 27, Abi. Then add your constant plus 250. This is it here. Just press your equals to. Within how many seconds we have an answer? That's 3,125. So as I've stated, you have to be time conscious whenever you are solving. When you get it, don't for instance start doing problem solving. Don't do that. But don't do the exam. Exactly. So when x equals to 15, I'm having TC equals to 125 in bracket 15 plus 5 in bracket 15 squared minus 15 cubed all over 27 plus 250. Right? So now let's expand. Like open the bra. So we'll see the content. 125 plus times 15.
Oh,
1,875.
1,875.
1,000.
875.
15 squared is what?
1,875.
They say 1,875. 875.
1875.
I mean,
Yes.
okay. Plus 5 into the bracket. What's 15 squared?
Just say it.
No, we did everything together.
Just do everything.
Yeah, 2 to 5.
2 to 5. 15 cube. 2 to 5, right? So what's 15 cube? 3,375, Abi. Plus 250, Abi.
I got to go 5 seconds.
So moving on, 1,875 plus this time this
1125.
1125.
125.
This divided by this.
125
125
plus
plus
250.
250. So put this
3,125.
125.
This might actually take 30 seconds. So you can save 30 seconds without solving. Just include your calculator, you have your answer. So the last time I asked guys to take notes. Initially, I go something like this. If you remember, do you remember? Where is the number?
Sorry, that question, it said where C is the cost of 9.
Where is C?
This is the cost of 9.
Cost of.
Cost of 9, producing excellent.
Can you erase it?
The question, they put that
Sorry.
let's see rupees the cost of 9 producing limit times 0.
Is the cost of money producing X rules. You can actually ignore it in the sense that when you have your total cost, when you have your TC equals to 9, all the things.
That's what that is.
I'm going to use it right now. So, can we move on?
Let us
Okay, initially, sorry, I stated something like this. Do you remember? What do you have here?
S equals to EX.
Are you sure?
Yes.
Are you sure?
Yes,
Is
sir.
that what you have?
No.
Okay, it's not almost guys to take note that whenever you have your variable as a power, the way you differentiate it won't be the normal way you differentiate it. We have a guideline you follow or a format you follow whenever you are differentiating it. Whenever you are differentiating sets, there's a format you have to what? Follow. Like what you have here. For instance, now if I ask to find the x all over the other x, right? You won't say r not you won't say that minus 1 for the power and carry the power to the back. No, that's wrong. That's not how we what differentiate it. Rather, this format we follow. We write the function. What was the function? E raised to power x. Exactly. then multiply by the derivative of the power. Derivative in the sense that the differentiation of the power, differentiate the power. What's power here? X. Remember, I told you guys that this triangle mark means what? Differentiation.
Yeah.
Then multiply by ln E.
A.
This multiple there, don't worry, very easy. That was all. I'm not related to it. Ln means natural logarithm. But I'm going to that. That's not of course what's in this class. So this math you are following whenever you are differentiating any time that the power has a variable. Might be 2 raised to power x. It might be 10 raised to power x squared. And they also find the derivative. We follow this format. I'm still coming to that. So take note, e raised to power x times derivative of the power times ln E. If you check your cash calculator, not your Y calculator. In the second rule, you will see ln. It's not I, it's small letter L. You not say E. Ln. You say ln. This is it here. Sorry. Ln. You can see display the ln Abby. Remember, it said E. If you check the stuff that is on top, alphabet on top, you see something that looks like E here, orange. So for me to press, I have to press shift, which is orange, shift and that. So you have E, right? E. There is a bar there. Mean that what's the power of E here? Let me ask.
X.
X.
The power, no, it's not this E here, not the other one. This is 0.
This
One.
Remember, any trace power 0 is what?
1.
Well, that doesn't apply here. But technically it's not 0. Not 0. What's power?
1.
It's actually 1. Like me having x. X is not
I'm
x raised to
confused.
power
What
1.
works?
What's it?
I'm confused already.
About this and about this E. X is not x raised to power 1. E is not e raised to power 1. That's not the super of 1. So this one, whenever the power is 1, we don't include it. You won't see them writing x raised to power 1. When the right was x. Same goes to the E2. They won't write E raised to power 1. When they write E. The reason I'm asking is, if they look at your calculator, it's actually to impute a power here.
Yeah.
So, which is what? 1. Sorry. We are having 1. I'm trying to prove that ln E is the same thing as 1. You can see the calculator just proved that part for us, isn't it? So, yes, to define this, we are having E raised by x. What is the derivative of x? If you differentiate x, what do you have?
1.
You all agree with that? Have you are lost? You are lost, have you?
No.
Do you agree?
Yes.
So remember, okay, so you're having 1 times 1, right?
Yes.
It means the x all over the other x is equals to e raised to power x. Clear?
Can you use that instead of using that E now? Can you use a number?
A number.
I have a question.
Okay, go on.
You know we have e raised to power x times x differentiated times ln E. So that E attached to that ln, would it be the same as this e raised to power x?
Nah.
Or is this just like a formula?
This e here is talking about the base. Let me even explain. Ln of the base. Let me do another example so you get it now. If I'm having y equals to 2 raised by x, you can see this one, in the part that part, we have the variable. So how do you differentiate? So follow this format. The y all over the x. We write the function 2 raised by x times differentiate the power times ln of the base. You get it now?
Oh.
Yes, sir.
This was ln e. The base is e. But the base here is what? 2. As we were having x squared, it will be differentiate, okay, write the function AB, which is this, times differentiate the power. You can see, times ln 2. Is that clear?
Yes.
So if now move on here, we'll be having 2x squared, which is the function AB. Differentiate x squared, what do you have?
2x.
2x AB. Then press ln 2 on your calculator.
0.693.
For most times, it should be just looking like that. Ln 2 AB. Multiply all through. We are
I'm already showing 0.
lean 2.
Serious.
Yeah, 0.69. It's not 2.2.
You said 2 points.
0.8 is correct. So here,
They don't accept.
you observe that this 2x squared is written as y abi, isn't it? When I'm writing this, I just put y times 2x times ln 2 abi, multiply or 2xy ln 2.
Wait, to see from that second to the last line.
On this part abi.
Why did you say 2x squared is the same thing as y? Oh!
So I just want to, instead of writing it, I know instead of writing this, something like this, instead of writing this, I want to make it in more simplified form. Remember, this is y abi, so we replace it with y, which is this, and your 2x, which is this. Do I come again? It is all y. Y times 2x ln 2 abi. So this is the same thing as 2xy ln 2. Like this y, 2x.
Okay. But since we already got the figure for.
It depends. The thing is like it depends on the nature of the option. Most times to come from this form, it will be in decimal. You can actually go now and input your name. To know if it's decimal, that is why I did not input it there. That So is that clear now? Like how to differentiate some that are already variable as in. So already count as a variable. But how do you integrate the opposite?
Do the opposite.
No, exactly. Remember, I told you guys that differentiation and integration, they are more or less of more than opposite. We are still applying this format, but in the opposite direction. Remember, what's the opposite of multiplication again?
Division.
Division. So if I'm to integrate this, like the integral of e raised to power x dx will be equal to rewrite the function as
Yeah, she goes to
e raised to power x. Why is it times divided by exactly differentiate the power times dx. Still the same format, but just doing the opposite thing. That's why rather than multiplying here, I want divided. Hope that's clear. Clear? Can I go on?
Wait, let's present. Process of the PC.
Lean.
It's not in green. It's more than I know. Okay, so the quick question of that. The simplification of that complexity material, example 3, can you do it? Page 57. Drop it on the group. Drop.
What's the simplicity stuff?
It's in part by Henry Infinity.
Get it.
So we want to get part in the end.
Are you want to get it? Are you pressing our page?
I might.
I press it. I call it.
Have you sent
I
it?
give you.
No, leave me.
Slide Abby.
If you need to sorry for dragging the back.
Okay.
This place, the equation is already set up. The e equals to e raised to power 1. What does it mean?
We're asking about this. What are you asking about?
Okay.
I was trying to say that e is written as e raised to power 1. Like the power of e here is 1. Remember when we were replacing our calculator, you said that the e is what?
Yeah, I'm trying to like write it out, so I'm trying.
Say it's articulation. So let's think about the question together. Is with respect to this. Please just note, I was only proving. If you are differentiating e raised to power x, it is e raised to power x. If you are integrating e raised to power x, it is what? E raised to power x. I'll show you. Because you're having e raised to power x, right? when you differentiate e raised by x, what do you have? E raised by x, isn't it?
Yes.
When you integrate it, you will still be having e raised by x.
Yes.
Okay, just have your k and b, isn't it?
Yes.
So if the question itself is e raised by x, don't go through this process. Just know that the differentiation of e raised by x will give you e raised by x. Getting it confused? Okay.
It's not e raised by x like that.
Yes.
Which other e raised by x are you talking about?
The answer.
The answer.
Look at
E raised by x is also
this is the question, Abby.
Go on.
When you differentiate e raised by x, you are still having e raised by x. Like the y all over the x. The y the function, right? Which is e raised by x. Multiplied by the derivative of the power, which is 1, times mean e, which is still 1. That is why you are still having e raised by x. So in the question, if you are something like 2e, sorry, you are something like x squared plus 2e raised by x, and they ask you to differentiate. Just differentiate this normally. You are having 2x, having. You know what happened here?
Yeah.
Remember, what is the derivative of e raised by x? What is the derivative of e? Is it not e raised by x? Now I'm just trying to start and bring. Let us bring this. Like, skip this process.
You're supposed to wait.
Like, skip this process, skip it. Exactly. But if it's something like, if it's not this, you have not like this.
Wait till you integrate.
This is different. This is what?
If you into okay, it's like you don't get my question. What I'm trying to say is that, for example, I'm trying to like follow what is talking. You know, we have y equals to 2 raised power x squared. So I'm telling you that this e raised power x would like that e can you also be like something like 3 raised power x. Is it the same?
I've said it before that whenever you are differentiating something that, whenever the power of the exponential has a variable, this is the format you have to follow when differentiating it. You can have something like this. Yes, you can.
That's not what I'm asking.
Yes, what is the question?
Yeah, I'm trying to say, you know, sometimes you can, let's say, you know, this is like just a formula now. That is e raised power x. I'm saying that that e raised power x could it be something like that being replaced with like e raised power
Yes,
x.
it's
And to say we say
E raised by
e raised power x.
Let's. I don't think so. No. It's only if you do the 3, it's not going to.
Okay, so we used to have a question that okay.
Yes.
It was not all the time. That's not that way. That's what I'm listening
Because there was no this house. So it's that sense is which that's integrating.
So I'm back again.
Integrating
We just need that.
Okay, it's not a situation whereby we are having, not that having e, we are having 2 raised by x and b. That's what I mean. It's not in a situation whereby rather than having this e, we are having another number like 2 and b.
What's now asking that whether if it's now y equals to 2x, no, you're not understanding. See, what is asking that if they tell you to differentiate 2x now, will it still give you, so it's 2 raised to power x, will it still give you 2 raised to power x as the answer?
Yes.
That's what I'm trying to answer. You know, you are using letter now. What if you substitute with like a number, 2 raised power x?
We solve it first. We
You
see
can see if you solve it. We write
You
it
still have
on
it too now.
Okay, no, it's
it won't, you can't do it.
Remember, yeah, we're having the 2.
Yes.
and the 2 is not 1. They will be having 2 raised by x and b times 1 times the 2 and the 2b. Exactly. So it will be like the derivative of.
It's okay. Look at that. That's why I got confused.
Yeah.
I'm trying to like put everything together. No, the second column.
The other,
Yes.
Yes.
We did something like ex square times 2x times e.
Yes. The e is 1.
Base.
Mean of the base. If you can press the calculator, you have
No, wait.
It's not much.
is the base, you are talking about what the base is. I think that's not the found. That's the base.
I was thinking it's next thing. Power.
E raised by x. Or O2. What is there now? What is there? The question.
I understand, but I want
The question.
The marginal cost function, let me say, is 2 plus 5x.
The marginal was. We are giving the marginal cost function as what?
2 plus 5ex.
2 plus 5x.
5ex. E raised by x. Yeah. Find c. Abina.
Find C.
Find c. E.
That's our total cost, right?
Yeah.
How do you get your total cost?
We'll integrate that one.
Integrate your MC with respect to what? X, right?
Yeah.
So now moving on, we have the integral of.
That's 2x plus 5dx.
X, abi?
2 plus 5dx again. 2x.
Integrate to what they are?
2x.
2x. Integrate e raised by x, what they are?
E raised by x.
Only for it to go through this stress.
Yeah.
Then plus k.
Sorry, if you are differentiating EX and
It's the k. So we
But
put that
it's
here.
divided by 1 again.
Still the same.
I keep forgetting k.
But if it's not e raised by x, it will be different. As soon as e raised by 2x, please do this. As soon as e raised by 3x, please do this. Exactly. But if it's e raised by x, don't go through the spread.
No, we have been studying now.
So it's now for the question.
Okay, find c. If c open bracket 0 now.
Find c. If what?
If c open bracket 0 is equals to 100. Find, and the second one, find AC. Yeah. Find average cost to the second one.
meaning to stop doing
Please take notes.
Boy with glass. Phone.
Please how the cost function
Boys.
comes
Cruising on the
out. Find that the cost function
Find boy on the chest.
is equals to variable cost plus fixed cost, right? In the sense of me having this.
Divine. This can I use that for you?
Do you get this? So if you have something like this, I believe we've done function
Okay, we can't charge this.
very in secondary school or before. If they say that this, it means
That's on that space. Charge.
right? If they say this, it means right? So this here, see, initially at the beginning of this class, I stated something. Let me see guys can still remember. When output is 0, what happened?
TC is equals to FC.
This is equals to what?
X.
Yeah, after 0 will be. So if after is 0, what is our fixed cost here?
100.
100. Because without solving, we know our fixed cost. But if you still want to solve, look at it. C of 0 equals to 2 into the bracket 0 plus 5 increased by 0 plus
100.
k.
100.
Abi, but it will be different in this case. Why? Because of e raised by 0 won't give us, like this, okay, sorry, this e raised by 0, like this here, won't give us 0. Can press e raised by 0 calculator, that should be 1. 1, Abi.
Yes.
So this will cause the problem. Exactly. This here will cause the problem. So here, you actually have to solve. It says when c of 0 is equals to what? When our cost is 100. 0 Abi. 5e bracket 1 plus k. So for the like terms, 100 minus 5 equals to k. 95 equals to k. K equals to 95. That way. So this thing, well, as we have the normal expression, we would have said since x equals to 0, tc is equals to fc, right? But this is not a normal equation. We're having e. Is this e that caused the problem? Exactly. And e raised by 0 is not 0. It's actually 1, right? That was possible. That is why we are having 95. You should use your fixed cost. So our fixed cost here is 95. So meaning we can have, let me manage this part. Meaning we can have c equals to 2x plus 5 e raised by x plus k. When k is 95, Abi, c equals to 2x plus 5 e raised by x plus 95. This is our cost function. And the question asks us to find our AC. Remember, AC equals to TC over x. That is 2x plus 5 e raised by x plus 95, all divided by x, Abi. 2x divided by x plus 5 e raised by x divided by x plus 95 divided by x, right? So moving on, this cancel out this. 2 plus 5 e raised by x divided by x plus 95 over x.
Well,
That was all. You have a question? No. Now go on and ask me.
okay, I understand what you did here, but I have one question. You know, we differentiated that structure. Sorry, integrated.
Yes.
Is the 5 different from the EX?
Okay, this was also the problem, Abi. How do you differentiate 2s squared? Remember, this is now 2 times s squared, Abi. How do you differentiate s squared? The derivative of s squared is what?
I'm differentiating
S squared.
what now x squared?
Yes, s squared minus 2.
Yeah, I'll differentiate. I'll 2 times x minus 1. 2 times x, then 2 the power.
Let me find out, sir.
2x.
2s, Abi. 4s, Abi.
On your side. I'm alone.
Right? This is said now 2 times s squared.
This 2 times 2. This for x.
Oh, we don't have 5.
We should differentiate this for x. 1. 2 times 2.
I'm joking with this one.
Okay, yeah, this way. This, focus on this, what I have very differentiate it. 2 times, Abi. Differentiate s squared, what do you have?
2x.
And this is has 2 times 2 times x.
Uh-huh.
Right? What was 2 times 2?
4.
That is why the derivative of 2s will give you 4x, right?
Yes.
Now back to your question. It was 5 e raised to power x. That is as 5 times e raised to power x. This is a number. Remember, you don't touch the number, just leave it like that. Focus on the one that has variable.
Okay. But I don't. Please don't tell me snap it or something.
Exactly. Okay.
Wait.
So,
Everywhere. Can snap that.
so we've come to the end of today's class.
Done.